I've decided to go ahead and assign page 407. This is ongoing practice from lesson 11.4, I believe. And I'd like you to do, I've asked you already to do, well, 1, 2, and then also the preparing for module 12. I can't express to you how important it is that you start um, being able to quickly come up with multiplication facts, your basics, your ones times your ones, all the way up. You're up to 9 times 9, even beyond. But those things need to start becoming more fluent for you. Please find some things you can do online to help build those skills. If you want my help, you're welcome to email me, and I'll do what I can to kind of give you some guidance and where you can go over the next couple months, so that the basic multiplication and division tables can be just a little bit more firmer in your head. But let's go ahead. I want to go ahead and review how to do each of these. And so I don't know how long this video will turn out, but I'm going to try and make it pretty simple. What I'm going to ask you to do is, I don't really care how you came up with the answer, whether you multiplied the parts or used improper fractions. I'm going to just show you how I would do it, and then I'll allow you to kind of look up the answer and see if you came up with the right answer. So here's how I would do it. I would turn this into a multiplication problem where it looks like I'm going to use the use improper fractions method. So 5 over 1 is turning the number 5 into a fraction. To turn 3 1/3 into an improper fraction, what I'm going to do is I'm going to take the whole number times the denominator and then add the numerator. So 3 times 3 plus 1 equals 10. See how valuable, how important it is to be able to quickly have those multiplication facts in your head? I could tell you that 3 times 3 is 9, and all you had to do is add one more to get that 10. When you multiply fractions, we don't have to find common denominators. What we're going to do is just multiply all of our numerators and all of our denominators. 50 times 10 is 50. That's actually pretty simple. And then 3 times 1 is just 3. I don't want to leave it like this. I know that your teachers next year will be expecting you to be able to show this as a proper fraction. So mixed number is what we'll be looking for. So we're going to take that number 3 into 50, because what we're saying this is 50 thirds. So I want to find out how many groups of 3 there are in the number 50. I'm going to use the standard division algorithm. Should have written it over here to give myself more room, but I'm going to take 3 into 5, and when I do that, it can go in one time. Take 3 times 1, and I get 1, and then I subtract that amount. 5 minus 3 gives me 2. 0 gets dropped down to right there. Then 3 goes into 20. And again, this is that quickly understanding your division and multiplication tables. 3 goes into 20 almost 7 times. It goes in to 26 whole times. 6 times 3 is 18. And since we started with a fraction in this as an answer, what we're going to do, we don't have a decimal to or remainder to or whatever. What we're calling this is 16 2/3. So if you came up with, for an answer of 16 2/3, no matter how you came up with it, as long as you solved it by yourself, if you got 16 2/3, then you've got it right. Your next method or next way, I'm still saying I'm not going to necessarily have you do it one way or the other. Basically, I want you to know the answer, but I'm going to show you how what I would do to get to the answer. So I'm going to do the same thing because I prefer this method. I'm going to take 4. over 1, because 4 to create, if I'm going to make this into a fraction, I'm going to put a 1 below it, times, and then I've got to take this mixed number and make it into an improper fraction. 6 times 2 equals 12, plus 1 is 13. So I now have 13 halves, and 4 times 13 is a little bit more difficult of math, but I think we can do this. What I'm going to do is I'm going to double that, and then I'm going to double that again. So if I double 13, I'll get 26, and if I double 26, I get 52. So if I have 52 with my 2 is on the bottom, because I'm going to take the denominators times each other. So 52 halves. 52 halves is equivalent to a whole number, actually. It's equivalent to 26. If you came up with that as an answer, that's great. I'm going to show you a really quick way that is a shortcut. So this is where understanding how to find, to be able to reduce fractions are, and how you can shortcut that process and make things a little bit easier. I didn't like taking 4 times 13. What can you do? Well, you can reduce. I have 4 and I've got a 2. I can factor these 2 out, and then I can eliminate some of that. 2 goes into 2, so I'm going to reduce this. 2 goes into 2 one time. 2 goes into 4 2 times. You're saying, well, they're not in the same fraction. And in this case, it doesn't matter. 2 times 13, though, gives me 16. I'll promise that this next step will be much quicker. I'll pause the video and write in answers here shortly. The thing it asks us to write each set of coordinates has a list of ordered pairs, and we see we've got at the top of this one our x coordinate, and the bottom our y coordinate. We're going to do one from each real quick, and then we'll pause it and I will quickly go through the rest. So our x coordinate is 0 and 7.3. For this one, you can see that this is one pair. Here's a pair over here. So I see my y coordinates first, so I've got to be careful. My x coordinate has to go first. So 4 in this pair, 4.0 goes first, and then 1. Now I'm going to pause the video for a moment. It'll seem like it's going fast, though. There are my ordered pairs. Now I'll ask you to pause your video, take a look, and then compare to what you have. Then there's the preparing for Module 12. It says partition each dividend into parts that are easier to divide, then complete the equation, show your thinking. Okay. Partitioning the dividend. Okay, I think I see what it's saying. It wants me to break this up. I am going to warn you, I'm just going to do it with the standard algorithm. So I'm going to do the whole, I think they call this like a garage. We put 348 inside, and then we start our division process. Can 4 go into 3? It cannot. But 4 does go into 34. 4 goes into 34 8 times. I'm coming up with this quickly, and that's what I'm going to reinforce again, how important it is to understand how to do your basic multiplication and division tables. 8 times 4 is 32. 34 minus 32 is 28. We still have that 8 to deal with, so 4 goes into 28 7 times. So your answer for the first one is 87. Now we have 435 divided by 3. I think I can do that in this space here, so we'll just go like this. 435. 3 goes into 4 once. That gives me a leftover of 13. I went quickly. I already subtracted out my 3. So 3 goes into 13 4 times. That's 12 with a remainder of 15. 3 goes into 15 5 times. My answer for this one is 145. And the last one, 6 goes into 762. 6, 7, 6, 2. goes once. Subtract that out. I have 1 with a 6 that gets brought down. 6 goes into 16 twice. So I subtract 12 out. I have 4 with a leftover 2 that has to come down. Sorry for the mess. 6 goes into 42 7 times. So your answer here is 127. What is my big takeaway for multiplication, division, addition, subtraction? It's to know your basic facts.